Pandas df.apply unexpectedly changes dataframe in place. From my understanding, pandas.dataframe.apply does not apply changes in place, and we should use its return object to persist any changes. However, I found the following inconsistent behavior. Let's apply a dummy function for the sake of ensuring that the original df remains untouched. This behaves as expected. However, foo will apply the changes in place if we modify the way we initialize this df. I've also noticed that the above is not true if the column's types are not of type object. Why does apply behave differently in these two contexts? Python 3.6.5. Pandas 0.23.1.
Interesting question. I believe the behavior you're seeing is an artifact of the way you use apply. As you correctly indicate, apply is not intended to be used to modify a data frame. However, since apply takes an arbitrary function, it doesn't guarantee that applying the function will be idempotent and will not change the data frame. Here, you found a great example of that behavior, because your function foo attempts to modify the row that it is passed by apply. Using apply to modify a row could lead to these side effects. This isn't the best practice. Instead, consider this idiomatic approach for apply. The function apply is often used to create a new column. Here's an example of how apply is typically used, which I believe would steer you away from this potentially troublesome area. Notice that pandas passed a row or a cell to the function you give as the first argument to apply, then stores the function's output in a column of your choice. If you'd like to modify a data frame row by row, take a look at iteros and lock for the most idiomatic route.
Maybe late, but I think it may help, especially for someone who reached this question. When we use the foo like and then use it in, we won't expect to occur any change in df, but it occurs. Why? Let's review what happens under the hood. Apply function calls foo and pass one row to it. As it is not of type of specific types in Python, like int, float, str, but is an object, so by Python rules it is passed by reference, not by value. So it is completely equivalent with the row that is sent by apply function. Equal in values and both points to same block of RAM. So any change to row in foo function will changes the row, which its type is pandas.series, and that points to a block of memory that df.row resides immediately. We can rewrite the foo I name it bar function to not change anything in place. By deep copying row, that means make another row with same values but on another cell of RAM. This is what really happens when we use lambda in apply function. Complete code. Output.
If you want to do similar, please consider subscribing.